So today we're going to look at several AP Chem questions, and the FRQ here is selected from AP Chem Test 2014, question number 1. So as we see, the question says that we have a reaction of potassium iodide and lead nitrate. And question A says, for the chemical reaction that occurs when the precipitate forms, write a balanced net ionic equation for the reaction. So when it says net ionic reactions, we cannot contain any spectator ions, and therefore we have solution here in the bottom. The reason why we have only lead and iodine here is because those two form a solid, and the potassium ions and the nitrate ions are actually spectator ions. They don't lose or gain any electrons here. And we have the solution here why this is the this reaction is best represented by net ionic reaction. And question B, why we have to dry and weight the filter paper with precipitate 3 times. It's because that we have to dry it to make sure that there is no water contained in the substance, and therefore we have to dry it until the mass of the filter paper and the substance is constant. Question C, in the filtrate solution, the K plus is greater or less or equal to an NO3. NO3 ion, well, nitrate ions are actually more than potassium ions, because if we look at the question, it says a tablet is dissolved in 50 milliliter of distilled water and an excess of 0.2 molarity of lead nitrate, which means that the lead nitrate is added in excess, which means that we have basically a limited amount of it. So but we have limited amount of potassium iodide. We can see here 0.204 or 0.425 grams. So that therefore the amount of nitrate ions is more than potassium ions. Okay, potassium ions is less than NO3 minus because there's an excess amount of NO3 minus from lead nitrate. D, calculate the number of moles of precipitate that is produced in the experiment. So first off, we use the mass of filter paper and precipitate after third drying, which is this 1.698, and we subtract the mass of dried filter paper, which is 1.426 from the 1.698, and the answer, and we can get the mass of the precipitate, and then we just use the conversion factor to find the answer, which we have here. 1.698 minus 1.426 equals to 0.236 grams of lead iodide, and we use this times the conversion factor, which is 1 mole lead iodide over 461.0 grams of lead iodide, and we can get 5.12 times 10 to the negative fourth moles of lead iodide. And E is calculate the mass percent of iodine ions in the tablet. And we see that in the PB, lead iodine, the ratio of moles of iodine and moles of lead is 2 to 1, so that we can say that we can first figure out the amount of moles of iodine here, this step, and then use the conversion factor to find the grams of iodine. And then we see here there is a 0.425 grams of total of Ki. So we divide the result, which is 0.130, by the amount of 0.2425 times 100%, which is and we get 30.6%. And actually, this is Ki. This is a mistake. I just wrote. Question F. In another trial, the student dissolves a tablet in 55 milliliter of water instead of 50. Predict whether the experimentally determined mass percent of iodine ions will be greater, less, or equal to amount calculated in part E. Well, it's actually going to be equal, because adding the amount of water does not change the total mass of the Ki tablet, and we are going to dry all the water to make sure that there is no water left in the substance. So adding more water does not make any difference to the actual mass percent of iodine. So we have solution here. Mass percent of iodine would be the same, because yeah. And then we have the three multiple choices. And the first one, if the solution containing equal amount of AgNO3 and KCl are mixed, what's the identity of the spectator ions? Well, from our solubility rules, we know that well, first off, this is a double displacement reaction. So basically, the Ag and K switch places. And then, according to our solubility rules, that we know that something with nitrate is gonna be soluble in water. Therefore, KCl are the spectator ions, and AgCl are actually the precipitate of this reaction. So the answer choice is D. And we have the second question. Which of the following statement about the reaction given above is not true? First, the oxidation number of chromium changes from +6 to +3. Well, the oxidation number of chromium is +6 on the reactant side, because the oxidation number of oxygen is -2, and we have 7 of them, so 7 times -2 is -14, and we have 2 chromium, and we have a total oxidation number of 2-, so our 2 chromium must have the total oxidation number of 12. So the the oxidation number of each chromium is +6. And then it turns to 3+, so the first one is true. The second one, we have the oxidation number of iodine changes from -1 to 0. Well, on the reactant side, it says -1 here. And we also know that the oxidation number of element is 0. So the second one, number 2, is also true. C is the oxidation number of hydrogen changes from +1 to 0. So here on the reactant side is +1, and on the product side is also +1. So therefore the answer C is incorrect, and D, the oxidation number of oxygen remains the same. Here is 2-, and here it is also 2-, so D is correct. It is +1, and it's also +1. It's incorrect. And this is our final MCQ. If solutions of iron 3 nitrate and sodium carbonate are mixed, what would be the formula of the precipitate? Well, I have the answer here. It's B, because first off, the number A is not actually a substance. It does not exist, because the oxidation number of iron 3 is +3, and for carbonate ion is 2-, and this does not have it, and this is not neutral. And C, according to our solubility rules, this is soluble to water. So our precipitate have to be B, because carbonates are not soluble when they are bonded with iron. So the answer is B. And thanks for watching.